I'm going to combine the first two objectives together in the examples that follow. Example 1, let L be the line determined by points A, where A is 2, 3, and B, where B is negative 1, 5. And there's a lot of things they want me to do with these points. Plot them, label them A and B, draw the graph of line L, find the average rate of change determined by the points, and write the equation of line L. So to plot the points, just draw yourself a quick little Cartesian plane with the order pair 2, 3. That means you move right 2, up 3, plot the point, call it A. And B is at negative 1, positive 5. Plot the point, call it B. And we have done this. Draw the graph of L. Well, I will then connect these 2 points together with a line, and I'll label the line L. All right, I did that. Check. Find the average rate of change determined by points A and B. Okie dokie. So the average rate of change equals, well, if you want to do it from the graph, you can, but I'm going to go ahead and use my ordered pairs and just remind yourself, this is the x coordinate, that's the y, and those both get 1s, and this is the x2 followed by the y2. So it's y2 minus y1 over x2 minus x1, and I end up with a positive 2 over negative 3. So my average rate of change is negative 2/3. And I did that. Check. Write the equation of line L. Whenever you are asked to write the equation of a line, you always have to tell yourself, I need 2 things. You need a point and you need a slope. The point you need, you've got 2 points on this line. You've got 2, 3, and you've got negative 1, 5. It doesn't matter which point you use. I'm going to use 2, 3 just so I don't have to worry about any negative errors. And you need the slope of the line. Well, I just did that in part C. The slope I found to be negative 2/3. So with that, I'm going to plug it into my point slope formula. Y minus my y coordinate, 3, equals m, negative 2/3, x minus 2. And leave it like that. Don't solve it for y. I know probably somewhere along the way you were told to do that and you're compulsive to do it. Don't do it, because in calculus, if you make a mistake transferring it out of one form into the next, even if this form is right, if you switch it to another form and get it wrong, you'll get the question wrong. So leave it like this, because this will earn you full credit when the directions say write the equation. This is one of the many forms of the equation. Here's a second example. Given a point on a line with the rate of change, again, that's a fancy way of saying slope, with a rate of change of negative 2, find the y coordinate of a point on that same line with an x coordinate of 4. All right, well, how do we do that? Well, the first thing you want to do is figure out what the equation is of this line. And the equation of the line with this point in this slope, remember m is negative 2, is going to be y minus negative 1 equals my slope, negative 2, x minus 3. Right, there's the equation of my line. Let's plus this up. Now on this same line, there is an x value of 4. What's the y buddy that goes with it? That's what this question's asking. Find the y coordinate. So now that I have the equation, I'm going to substitute my 4 in for my x to find out what y is. And I know that y will be equal to, let's see, 4 minus 1, or 4 minus 3 is 1. So I get y plus 1 equals negative 2 times 1. I'll finish my work over here on this side. Y plus 1 equals negative 2, and then y is negative 3. And that would be my y coordinate. So my y coordinate equals negative 3. And that's it.